We are here kicking off Nodes AI. We're soon going to break into 3 tracks with more than 40 talks at the intersection of AI and graphs. And to start off, there's no better topic than context graphs, which has been a super hot topic the last couple months. And I have a distinguished panel of guests here. Let me go through and ask each one to introduce themselves.
Hey everyone, my name is Animesh Koratana. I'm the founder and CEO of PlayerZero. We're an AI production engineering platform and super excited to be here.
Glad to have you.
You wrote one of the best blog posts on context graphs a couple of months ago. Yeah.
That's awesome. So Lasse Andresen, I'm a founder and CEO of IndyKite, kind of like the application infrastructure for AI, specifically trying to build a control plane and talking to all the different data out there and then also controlling all the access.
And my name is Will Lyon. I'm a product manager at Neo4j on our AI innovation team, working on building tools for making it easier to build and orchestrate your agents.
So my name is Emil Eifrem. I'm the founder and CEO of Neo4j.
All right, let's jump in. Animesh, let me start with you. Jaya from Foundation Capital was scheduled to come today, unfortunately was unable to make it. So I'm going to ask you to channel her a bit.
I'll do my best, yeah.
She wrote this incredible post in December where she actually referred to your company. And it clearly hit a nerve. It went super viral.
Yeah.
Why do you think it hit the nerve? What nerve did it hit?
Yeah.
And what's the real opportunity here?
So, the context graph piece really went viral. I think the thesis was that 2025 was supposed to be the year of agents in the enterprise. And as the year went on, it became really clear that there was a gap, right? Agents were creating really cool demos. They were able to stitch together, different systems of record, do work that otherwise was, purely done by humans in the past. But as these things started becoming, more and more deployed in production scenarios, there was, something missing. And I think context graphs went viral because they took a prescriptive stance on what that gap actually is and how to close it. And so the core idea behind context graphs was this idea of a decision trace, which is for every single thing and outcome that ends up being stored in the system of record, there's a bunch of decisions about why that end up being lost. And if we can capture that, then we can start creating a new form of externalized institutional memory. And that ends up being kind of the missing link for agents to be really productive and effective in the enterprise.
So separating the system of execution from the system of knowledge and memory is a key part of this.
Exactly.
And can you talk more about decision traces? Let's drill in one more level. Yeah. What is that actually?
Yeah, I think a good way to think about this is to kind of reverse engineer the outcomes that are stored in systems of record. So let's take something simple, right? We think of Salesforce, right, as a system of record, and it's a system of record of customers. And so when a deal is stored in Salesforce, we end up storing something on the order of, we closed this customer for $100,000 and, the renewal is coming up in the next 12 months. The entire negotiation of how did we get there, right? Oh, we're at the end of the quarter, they had only this much in budget. These are the specific people that we talked to, and here's what their personalities were. We had this particular champion who was really liking us, but this other person was a detractor. All of those nuances end up being lost. And that ends up being actually really important. So that way, when we're actually looking at the renewal 12 months later, right, to be able to understand why the deal was closed in the way that it was. And that ends up becoming the decision trace, the series of kind of decisions that actually kind of led to a particular outcome. A context graph is basically a fabric of decision traces that are woven together. And I think the key insight here was as agents, instead of humans, end up owning these decisions, their trajectories actually end up becoming the decision trace, right? The agents are the ones actually making the decisions about, maybe we should negotiate in this way instead of that way, or we should offer this particular price point instead of that one. And, in PlayerZero's sense, right, we should, look at this service instead of that one. Right? And so these accumulated over many different agent trajectories end up becoming decision traces that can now all of a sudden be captured in a world where, for the last 2 decades, we never really could introspect into them.
That's great. Lasse, let me shift to you. You've built various technologies around graphs, previously at ForgeRock and currently in IndyKite. And you're building tools that deal with context graphs, but also infrastructure that agents require in order to be able to work with context graphs and decision traces. Give me your perspective from actually being in the process of doing it.
First of all, I think what you just said about the difference between 25 and 26, kind of like now in the enterprises, people know they have a problem, which is a huge thing. Of course, these agents, they are connecting to a lot of different systems. And they are making, the whole context graph actually becomes a decision engine. And understanding the context is core. And I think from a learning perspective, kind of like keeping track of all these decisions actually going to make the next agent or the next behavior or next action much, much better. So we kind of like been building everything based on a context graph out of the get-go. The flexibility, the kind of like the value it actually gives us is just kind of like super. Then we integrated that also with the core identity systems. Kind of like identity is kind of gives the birth certificate to the data. If you really can trust and know where the data is coming from, that sensor, that agent, or that human, you actually can say something about the quality or the trust in the data. If you then also have the context to it, and you can connect to all the data sources, you have a really, really nice, we also actually call it a system of intelligence. And the core to this, all the decisions, is the context graph.
What do you see these ingredients of trust? You kind of named 2, which is, are agents able to access the right things and not the wrong things? And that speaks data privacy and so on. And the other is the quality of decision itself.
I think it has a lot to figure out kind of like, where does the data come from? What is the kind of like quality of the data? And that can be a lot of different things. It can kind of like, can you identify the source truly? Kind of like, is the data you're using kind of, what is the timestamp? Is it kind of like 3 years old, or is it something fresh? Is it just a comment from one person? Is it actually proved? There's a lot of things that you actually need to combine to understand the trust. So we have something we call trust scoring, where we kind of like can decide what kind of elements needs to be in place for giving it a high trust score. And if you have a high trust score, you can tell the agent you can continue. If that trust score is not met, you shouldn't continue, or you should ask another agent or a human for interaction. So, and the trust of it could be a lot of things, like, as I said, location, where is it, who entered it, or to what, how did they get into the system, the age, and a lot of different things.
Cool, so context graphs actually encapsulate and bring in a lot of things. I was pretty tickled this morning on my way to the recording studio. I actually noticed that Gartner just this month published a piece with a hype cycle on AI, agentic AI, and context graphs now show up there. And they're actually reasonably far up the curve. Should the audience interpret this as a signal, whether they're an enterprise or a startup selling to the enterprise?
I think it is very telling that, Philip and I, we were presenting to senior executives at a big bank just a few weeks ago. And you pulled together a few Gartner quotes that were released just in February about the value of knowledge graphs and AI. And there's like several reports talking about that just in the last few weeks, right? And I think that says something about the maturity of adoption in the enterprise for knowledge graphs, broadly speaking. This is nodes, so this is about not just context graphs, but knowledge graphs and AI, broadly speaking. Specifically for context graphs, at least what we see in the Neo4j community is that it's the kind of the normal spectrum of startups are much earlier adopters of context graphs.
Will, I'm going to turn to you. You've been turning prose into code from the perspective of actually education and synthesizing things that we're seeing in the community and helping people with examples.
The post in January was largely a look at what does a full stack context graph application look like for a financial services agent? And so it's a demo application that's, let's say you're an analyst at a financial services company. You have credit requests for approval coming in, you have customer service things coming in. How can you leverage some of the institutional policies, the decisions in a graph to help the analyst in a agentic setting make some of these decisions? And I think that was a good one for me just to understand, okay, here's the pieces of how we build up a context graph. Ideally, we have data from different systems. This is the requirements for how we stitch that data together, what that looks like. And then a lot of good feedback from folks in different industries. I said we built this demo for financial services. I had folks saying, well, it'd be great if we had an example for car manufacturing or for whatever it is, right? Initially, there's like 20-some domains, but really the idea is with a single command, can you create a full stack context graph application with data, with an ontology that defines the domain data, how all these things fit together, and then also connect to real world systems like Google Workspace, Linear, pull in your your Claude Code sessions to look at where did these discussions take place? How do we actually make decisions in an organization? Well, we do this by conversation, by discussion. And while not all of these thoughts are encoded in like work product, we have much of this discussion in comment thread in a Google Doc, in discussion in a Linear ticket. And so that's another piece of this Create Context Graph tool is really, can we search through the history of those discussion threads, surface how did a decision come to be, and can we materialize that in the graph? So that's kind of the goal of that project that you mentioned. Like first, get started with some real world data, and then also giving this in a full stack application context as just a way to get started.
Lasse and Animesh, let me ask you, having built applications, what are some of the learning surprises, gotchas that you've experienced in the course of building what we're talking about?
I think there's a couple of things, and it's kind of like two sides. One thing is kind of like being the context graph, being the decision point. Of course, you can definitely use that for learning, for next time you're going to make a decision and record that. But also you have from security side, the governance side of the traceability, kind of why did this happen? And in the old days, kind of like, yeah, we are logging everything, but the logging is just event. They don't understand the context at all, and it's too late, and it's afterwards.
There's no feedback loop.
There's no feedback loop, and there's no learning in that. It's kind of like coming in and looking for something that happened yesterday. Well, why bother? So what we see is kind of like people are using this for both kind of like having agents to be better, decisions to be better, but also again back to the auditability, the governance, the traceability of stuff is core. And since kind of like AI agents are pulling information and data for so many different systems, how are you actually going to put that together to understanding the full decision, why this happened? And this is where context graph is definitely the best solution.
Yeah, to actually second what was said just now, like the real challenge with building a context graph is figuring out how to instrument the decisions. If you can do that, the rest of the structure, the representation, the learning, all of these things follow. There's this question that I get often, which is like, are context graphs an application layer or an infrastructure layer opportunity? And I think the reality is it's kind of both, right? And the application layer opportunity is like, you have to find the right UX to be able to actually instrument the place where the decision's actually happening. And I think agents kind of change the UX in some really positive ways, so that way they can actually own decisions, right? For us, for example, right, when a ticket is created, everything from the problem happened to where do I look to who do I go to what does the solution actually look like, an agent can own instead of passing from support to engineering to QA and so on. So I think that's one non-obvious sort of realization where this is actually a little bit of a UX problem just as much as it is a infrastructure and continual learning problem. The second one is, and I think this is going to be increasingly important as agents kind of scale in the enterprise, is governance, right? Agents, and I think we've kind of known this as we've started deploying agents more and more in enterprise, like us as a community and as builders in AI. But there's this realization that agents are really good at figuring out how to solve problems. And in order to do it, they're able to fluidly navigate data. They're able to pull records from Salesforce and from Linear and from GitHub and code bases. And there is no parallel for that as a human, right, in most of these enterprises. For example, at a large bank, there's no single person that has access to the full kind of ticket history, the full code base and all these different things. And so we say that an agent can do all this work, but it has to be governed, right? And so the access and kind of partitions of this context graph need to be governed in a way that intuitively makes sense to the kind of the governance models of these enterprises. And I think that's a secondary challenge with building context graphs in the wild, but huge kind of potential and opportunity there.
One of the things that you spoke about really well in that initial blog post, following up after Jaya and Ashu's one, was around ontologies and kind of your view on, and I'll probably bastardize it here, and you should play back the real version, but like some version of empirically discover bottom up the ontology or the schema, the metadata layer kind of the universe, right? And then I hear you saying that in kind of create context graph, you include 22 plus kind of ontologies, which I think is really powerful, right? Which represent more like the top-down thing, and then maybe your approach that represents the bottom-up. I would love to kind of see if we can reconcile those. Are they in conflict? Are they complementary? Right. So first of all, maybe Animesh, did I bastardize? Okay. Maybe you can speak to how you do it in kind of PlayerZero, and then we can kind of figure out what the
absolutely. I think like Philip, your point about starting with a problem is basically the way that we've started as well. First we're a startup, and we have to start somewhere, and where we chose to start is thinking about kind of the unplanned work that shows up in the plate of engineering teams. This is a support ticket, this is an incident, this is a problem happening in your software. And now different groups of people have to go and deal with it. Now, in the process of doing that, right, we have problem-directed agents, right? Receive this incident, receive this ticket. And in the process of actually going and figuring out why this broke or how this broke and what do I need to do next, right? It's starting to stitch together these different systems of record, maybe past resolutions. I have to go look at, last time I asked Emil, right? Why did we deploy this service in this particular way? Right, and so there's.
Why did you deploy that?
I don't know. I still don't know. But there's agents are really good from like a problems like directed standpoint, right? To be able to take a problem and actually start stitching together context across all of these different places. And if we observe how are they actually navigating that context, that's where we can actually start learning kind of the structure of a existent but unobservable context graph. Right, we're starting to kind of see the nodes in the graph, and we're starting to see how they get related. And then from there, right, we have more agents that you've made the code change, and now let's simulate whether this thing might actually break or not in the future. Right, running verification, running review, running kind of intent-based documentation, and all of these different things. And so you have agents that are actually reinforcing the graph from the other direction as well. Right, about trying to take intent data and start moving it into the central representation. And so the idea behind PlayerZero is that we start with a wedge, and a wedge that will actually solve a problem for you right now. And that is, there's some fire in production, let's go fix it quickly. And as we do more and more of that, we start learning, how do we make decisions in our engineering team? How do we short circuit that next time, right? Why did we build this in this way, and what did we verify? The next time some sort of code change happens, we can actually go and verify that these changes aren't going to reintroduce the problem that we saw in the past. And these are all things that are ultimately being learned into this context graph. And this whole thing kind of accrues and it builds a flywheel, right? Kind of into this context graph. So Emil, to your point, this is completely discovered, right? There isn't a single ontology that we go in and say, this is exactly how this enterprise's context graph should be looking. Here's what the relationship should look like. It's very problem dependent. And because of it, actually, a lot of our representations in the context graph end up being represented in embedding space, right? So there's actually learned representations of how different records across your entire system are actually related to one another. So it's very different. And actually, the way we talk about it is, a context graph that is really well tuned becomes a world model.
Yeah.
Right. It's
Enterprise world model.
An enterprise engineering world model. Exactly.
And when you say embeddings, I'm pretty sure everyone here is on this page, but you mean graph embeddings, GNNs, not word embeddings.
Not always. Oh, so they're structural embeddings.
Yeah.
Actually. They're structural embeddings. So they don't always, again, the graph is not fully observable. It needs to be discovered. And so as we keep doing more and more work, we're starting to understand the structure of sub-partitions of that graph. But the embeddings themselves are structural relative to other nodes that are being discovered by the agent.
Cool. So I want to hear, Will, is that in opposition to
Very curious.
your view, or is it complementary in some way?
Yeah, well, the way I think about it, I think there's a close overlap. It's not one-to-one, but there's a close overlap between agent memory and context graphs, right? And with agent memory, we often think about short-term memory, long-term memory, and then reasoning memory. So short-term memory, this is like the length of a conversation. Long-term memory, these are like entities that we've extracted out of the conversation and how they relate. And then reasoning memory, this is like procedural memory. This is the how agents plan during the reasoning phase, what tool calls they make, the result of those tool calls, and this, I think, the reasoning memory is an important part of the context graph piece in that it's understanding what did we do last time and did that result in a good outcome and making those traces available to the agent during the next reasoning phase, right? That's an important piece. I think that on the question of ontologies and data structures ahead of time, because we're talking about unstructured data, we're working with agents, so there's a lot of text data, like conversations, documents, emails, this sort of thing. And anytime that we're working with unstructured data and generating a knowledge graph, the success of that project, from what we've seen, is largely dependent on the quality of extracting those entities, doing the entity resolution, going from unstructured data to your knowledge graph. And by applying a data model, an ontology that maps to your business domain, you are able to increase the likelihood of success because now your knowledge graph is more closely mapped to the data that you care about, right?
And you're talking about like SKUs, customer names, things that are well-known terms in the business that you can apply to your graph extraction.
And that's exactly in Create Context Graph that we're talking about. That's exactly what the ontology is. It's just the data model, the domain that is relevant for healthcare versus financial services versus manufacturing. And so as we're going through the entity extraction resolution pipeline, we're doing that with that data model, with that ontology in mind, so that we're extracting information about drug discovery and drug protein gene interactions. And if we're manufacturing cars, we're extracting information relevant for that process, right? So that's where I think the power of the ontology comes in, is during that, informed construction of the knowledge graph phase, which I think is an important component, like just one component of the context graph.
So for those of you who have been with Neo4j for a while, this is the Nodes AI community. So we have several people here like listening in that have been using Neo4j probably for 5 years, 10 years, maybe 15 years, right? We, in many ways in the graph world, represented kind of the bottom-up approach, right? Where it's like, okay, in the world, this other alternative way of expressing graphs called RDF, then you tended to start with an ontology, right? And it was more top-down, and it was more kind of upfront work. And we said, you know what, schema-free is really powerful. And I always had the perspective, as you well know, of schema-optional. That's the thing, like, so you can start in a schema-free way, and over time you add more kind of schema-rich constructs, right? So that was always kind of the point of view. Where I sit today, now that we see basically two things change. One is Neo4j is being more frequently used by multiple applications at the same time. Like a single Neo4j instance is used by multiple applications at the same time. That's one thing. The other thing is what Will spoke to, which is importing unstructured data and trying to create a knowledge graph out of it. Both of those are real drivers of having a better understanding of the schema or the metadata model or the ontology for that domain. And so it's actually an area that we're going to invest a ton more in the product over the next couple of quarters. And you're going to see several exciting releases from us over the next, just few months in this area, actually. And so I actually think it is one of those best of both worlds. You want to be able to do it completely bottom up and discover it and completely build it in that way. But being able to marry that with a top-down view when appropriate, I think that combination is really powerful. Hard to implement and do well. The kernel team, the database kernel team, is kicking us, right? Because it'd be so much easier if you do choose one. But having said that, if we can pull it off in a good way, that I think is the best of both worlds in this.
And I'll actually put in a plug for Create Schema, which is in early access currently, which for the first time lets you define a schema and associate various kinds of constraints with it. So encourage the audience to play with that. Thank you. Thanks all.
Amazing.
Thank you.
Thanks
Enjoy the
everyone.
day.
Thank you.